Welcome everyone to our introduction to Git and GitHub. And before we get started, we would like to acknowledge the traditional owners of the land on which we are gathered today. And for us here in St. Lucia, these are the Turrbal and the Jagera people. We want to explain quickly our teaching approach today, just with bikes. And most quick guides to Git are actually very, very detailed and explain you what every function does, what every little piece of Git does, but it's really hard to understand how it all comes together if you've never seen anyone riding a bike. And that's why the tutorial we'll attempt today is I'll just get on a bike and Stefan will explain what's happening in the background. And quickly who we are. So my name is Saskia Bollmann and I'm a postdoctoral research fellow at the Center for Advanced Imaging at the University of Queensland.
And I'm Stefan. I'm the 7 Tesla National Imaging Facility Fellow at the center. And if you have questions to our talk, there will be the teaching assistants that will help out in the chat of the meeting. We will also be there to answer questions. There will also be a help desk channel on Mattermost, and there will also be a Jitsi room where we can talk.
And if you want to have a look at the slides, we'll put them up on our website, mri.sbollmann.net. Cool. So we will go through 4 use cases with you today, just using some code you found on GitHub at the first step. Then we show you how to use version control for your own project, then how to add someone to this project, and then the last stage, how you contribute to a larger project. Okay. So let's get started with number 1. For that, I just went online and searched for a nice example. So I chose fractals in Python, and I just searched for a GitHub repository where some code is provided by someone. And we just click on the first link, and that brings us to the GitHub webpage of that repository. And you can see the name of the repository, the owner, a quick description of what's in the repository. So for example, what programming language is used, and you can see the content of the repository. When you scroll down, you will get to the README, and that really explains and documents what's in this repository. So here we just have a collection of Python scripts for drawing beautiful figures, and that's exactly what we want to do here today. And as a quick intermezzo, we won't go into details, but we have put a few slides how to install Git and also how to create a nice development environment for Python. We won't show it, but we just want to say for our examples here, we use Visual Studio Code to also highlight a little bit the integration of Git with integrated development environments. And just to let you know, most IDEs like PyCharm, MATLAB, or Studio already have this Git interface, which makes the workflows much more nicer. Cool, so once you've installed Visual Studio Code, but you forget to install Git, it will tell you to do so. And once you've done that, you're represented with 2 options. You can open a folder or clone a repository. And today we want to clone a repository. So do you know why they called it cloning a repository?
Yes, so cloning repository is a Git terminology, and it basically means that we make a copy of a repository from a central server to our own computer. And we only use the word cloning when we do this for the first time, because we copy the files, the working copy, and we also copy the repository, and we establish a link. So the repository knows where it came from, so we can later push content back to this central repository. And as an example, here we have our PyWonderland scripts that this author has on his GitHub account. And then we clone this repository, and we end up with this repository on our computer. And then we go from there.
Exactly. So Visual Studio Code will ask us for the repository URL, and that's something we'll find on the web page. So when you click on the clone button, we'll have this little window pop up, and you just need to click on this button and we'll copy it. And you can then enter the URL of the repository into the Visual Studio Code window, and then it asks you to select a repository location, which is kind of like the location on your local computer, on your local hard drive where you want the repository to be. And once you've selected that, it will start cloning the repository. And once it's finished, it even asks you, would you like to open that? And yes, we want. And once you've opened that, you can see we now have the same content as we've seen online on our local computer. So now that we have it, we can have a quick look on what a repository actually is.
Yes, so what do we mean with repository? So when we look at it in Windows, it's a hidden folder. So if you don't see it, you have to switch that you want to see hidden files. And it's a .git folder. And this .git folder contains subfolders like hooks, info, logs, objects, refs. And if you look in these files, they're quite cryptic. So you can't really see much in there, but this is actually the repository. And then outside of this repository, this is what we call the working copy. This is the actual files you're working with. And then Git provides tools to explore this repository. So here, one example, git log shows us a commit hash. We'll show later what that is. We'll show on which branch we are, where things came from, who the author is of this code, when this person made changes to the code, and what the person changed. So a repository is a virtual storage of these project files, including its history. And they're basically snapshots of files together with commit hashes.
Yeah, and as we pointed out, it's kind of like the same principle in other IDEs. So whenever you start with a new project, you want to pull something to, or you want to clone something to your local hard drive, you look for the clone repository option, then you give the URL, and the rest will be done for you. And just as a quick summary or overview, you can see on the left-hand side, that was the remote code that we wanted to get to our local hard drive. And on the right, you can see, okay, we now have exactly the same content on our computer. So can you explain what remote means in Git terms?
Yeah, a remote is simply a repository stored on another computer. And you see often the word origin. And origin is the name for a certain remote, and it's the name for the remote repository where we clone from. So in our example, we have the repository of the developer, which we clone from, and it's now locally on our disk. Now we would call this a local copy of the repository, and the remote where we clone from, we call origin. And later we will also see other remotes that we can have in Git.
Exactly. Now we want to run the code. And that's really one of the nice features of using GitHub, because it prompts you to include the documentation of your code. Not only the code itself and its history, but also asks you please document how to use the code, for example. So that's part of the README, and we can look it up and we see, okay, we can just run the example Py scripts. And if you want to do that, you will need a few packages. And again, we have put a few slides in here for you that show you how to add them using Conda. And again, this is part of the README, so it really shows you which are the dependencies that you need to install to run that specific code, which if you only would have the code, you wouldn't know about. So that's really one of the big advantages of using GitHub. And once we've sorted that all out, we actually do get some fractals presented here for us. And right. So this was just a very simple run through how to actually clone something from a remote repository and run it on your computer. And we can have a little bit more of a look inside the history and what's happening. So this is now the history presented online on GitHub, and you can again see, okay, when something happened, who did it, and what that person did. And you see that the history is like written in commits.
Yeah, what is a commit? Committing a change means that we create a snapshot of the project's current status. So the current files that we have in our working copy, we change them. And then whenever we feel like that we made a significant change and we're done with developing a new feature, for example, we will do a commit. And one basic rule is try to commit as often as possible, because the commits don't cost you anything. So they're just snapshots and they're differences to the files. So it doesn't matter if you create once 10 lines or 10 times 1 line, it will be the same for Git. But if you commit very often, you have the chance to go back to these commits individually, and yeah, you get a more transparent way of what happened, how do you develop the project. And also one thing that is really useful is don't say in a commit message, oh, I changed line 10, because everyone can see that when you display it, so Git will display that. What you should put in your commit message is a clear message of the intention. So usually what I put in there is, I intended to fix this problem, because very often this is not what's happening. So it's always good to document what you try to achieve, especially when debugging, when you go back, you figure out, oh, okay, I tried to do this, and actually I broke something else. So that's a good hint.
Exactly. And we can also explore the history of one local file, and you can then see, okay, when was it first added and what were all the changes that were made for that file. And that's kind of like the version control aspect of Git. Cool. So in summary, we have learned what is a remote repository. We have learned the function of the README, which is really the documentation of the code. We learned about commits, that's how the history is written. And we've also seen what a local repository is, and the first Git command, which is clone. But at the moment, we are kind of like only a user and observer of the things that are happening. So in the next step, we want to do version control for our own project. And first, you go to GitHub and sign up. And then you create a new repository by clicking on that little button. And you're asked to give the repository a name. And again, you're also asked to provide a description. It's optional, but it's kind of like this prompt to already start the documentation right away. So once you've done that, you create this repository, and then GitHub will present you with a couple of options on how to actually continue from there. And we will follow the example highlighted here. So we will create a new repository on a command line, but you can follow any of these other options as well. So the first thing is you have to create a local folder. And the best thing is to name it exactly the same way as the name of the repository, just to avoid confusion. And then you open Git Bash. And once you've installed Git on your computer, this little icon in the context menu should automatically appear. And then we can just follow the steps along. So the first step is this one, which we just copy paste into the Git Bash command line. And what it will do, it will create a file, the README, and it will also add one line to it. And just to show you what's happening, so I'll see, okay, in my OHBM Git example spawn1 folder, I have now one file. And if I look at it, it exactly has this one line in there. So the next step is to initialize the new repository locally using git init. And once I do that, it will tell me, okay, it initialized an empty Git repository in that folder. And a usually useful Git command is git status, which tells us the status of our local Git repository. It tells us we have nothing committed yet, but there's one untracked file, which is the README, which we just created. And also tells you how to continue from there using git add to add this file to the repository. And that's exactly what we're going to do. So we will add the README to our repository and then check the status again. And we can now see, oh, wow, there's a new file that has been added. The next step is to commit our changes. And we can just follow the instructions. And once we put that, it tells us, okay, one file has been changed and one insertion has been made. And when we check the status again, we can see there's nothing else to commit, and our working tree is clean, which is really good. And now we have to add the remote to our repository. So remember, in the first step, we kind of like cloned the repository from the GitHub, so the remote repository to our local hard drive, and that automatically creates that link. We haven't done that here. We have initialized our remote locally, our repository locally, so we have to add the remote now also manually. And once we've done that, you don't really get a feedback, so you might wonder, oh, did it work, did it not work? When you call git status, because the status of the repository, so the files haven't really changed, it won't tell you that it now has this remote. And to get that displayed, you need to use git remote and with the verbosity flag to really see what has happened. And yes, the remote has now been added. And the last step is to push your repository up to GitHub. And when we do that, we will run into a problem because Git has some authentication. So your repositories are actually secured. Not everyone can, when it's a public repository, can download them, but not everyone can push changes to them. So we have to set up SSH keys to authenticate. And again, we have some slides in there you can look at and follow along the instructions to get that going. Cool, so once we've done that and we try again, this time we are successful and we can push our changes to our remote repository. And when we look online, we see that the README has appeared, our commit message has appeared, and also the text that we added to our README file. And for people who have used other version control systems like SVN, it might be a little bit confusing, the commit and push, kind of like this two-step approach. And I think Steffen will explain a little bit why that was introduced.
Yes, why do we have commit and push? And that's also something I wondered in the beginning when I started with Git, because I came from SVN. And there in these older version control systems, you have a central server, and what you do is your commit basically uploads your thing to the central server. And the problem with this is if you are working with hundreds of people together, this is really tedious, because what you had to do in the past is you had to lock a file so that someone else couldn't make a change while you were making a change, because that would create conflicts. And in the old systems, a conflict wasn't handled well. Whereas in Git, a merge conflict and merging is an essential part. So a commit is tracking or creating these snapshots locally on your computer. So no one else sees your commits, which is great, because this means you can also code in an airplane or in a submarine or wherever you are. And you actually don't need internet connectivity to code and to track your changes. However, when you want to change or when you want to exchange your history with the central remote, then you can just push. And push means you're uploading all your history to this origin in this case. And then that's where then merging happens and where merge conflicts would appear. But yeah, that's why we have commit and push. It looks more tedious, but it actually gives us a lot of flexibility, and it enables us to work together theoretically with thousands of people. And that's why Git was developed in the first place, because Linus Torvalds was sick of using these old version control systems. And I think they had to pay a license fee suddenly. And that's why over a weekend he wrote Git. Yeah.
Awesome, cool. So we can now continue to working on our project, so we can just make some changes online. And I just want to show you how the README actually works, so and how you can make it nice, introduce headings and stuff like this. So the README uses Markdown, and there it's a little bit like LaTeX. So you write how how your text should look like, and then it's interpreted. I'm just copy pasting that example here, how to make words bold and others italic, how to add links. And when we add that to our file, and then we preview the changes, we can see how we make that really nice and appealing for our users. And since that is a change of the file, I also have to commit it, also when working on the remote. And GitHub really makes it very easy. It asks you to give a commit message, and then you can commit your changes. And when you then look again at your repository, you can see, okay, now we have the heading and some text that I have just added, and that's a commit. If you now want to continue working locally, for example, using Visual Studio Code, you open Visual Studio Code and you're presented with two options. One is open a folder and the other one is clone a repository. In the first example, we used cloning a repository because we didn't have it on our local hard drive yet. But in our case now, we already have the repository locally, so we just need to open the folder. And when you do that, you can see that the README is there, but we don't have all the changes that I just made on the remote on our local version of the repository. So we have to pull these changes to update the local repository. And once I've done that, I'm up to date and can start working along. And for example, now I want to make some changes in Visual Studio Code. So I added the README, and then I want to commit that. So I'm creating the history and keeping track of the changes I'm making. When we do that, Visual Studio Code will present us as a question, present us with 4 options, and it asks, do you want to automatically stage all your changes and commit them directly? And for most of the people, the answer to that is always, but Steph will explain what's behind that so you know when not to click there.
Yeah, exactly. So the staging area concept also confused me in the beginning. And what it is in the end, we have changes in our folder. So this is our working copy, our working folder. And here I changed 2 files. So let's say I worked on ITK snap, and that's the actual things I want to commit. And then I have an unrelated file. What the staging area now allows me to do, it allows me to pick the files that I want to use and include in the next commit. So if I use the staging area, I could, for example, say, oh, I only want to include ITK snap YAML in the next commit. This is would be the modified one. And this unrelated file, I keep that for another commit when it's ready. And then when I do this, I end up in the repository with the committed change to this ITK snap file, but this unrelated file is not committed. So it's still kept as changed, and I can either never commit it if I only need it as a temporary file. It shouldn't end up in a repository, for example. Or let's say I'm still working on it and it's not ready to be committed yet. Then I can do this. But in most instances, I guess all changes that you made should end up in a repository. So that's why clicking always will just keep this a little bit simpler, and you actually don't have to use the staging area. But also, if you clicked always, and let's say you want to exclude one file. So let's say you accidentally created a big file in a repository. It's a temporary file, and now accidentally it's added. What you can do in Visual Studio Code is you can click on it and you can say unstage that file, and then it will not be committed with it. And then you can, for example, ignore the file in a git ignore file, which is very useful if you don't want to include temporary files, because that's not a good idea, as we will show it later.
Exactly. And so when we click on commit, and when we click on always, then Visual Studio Code will ask us for a commit message, and again try to not say what you actually did, but kind of like try to make an intention. My intention was to commit from Visual Studio Code. And once we've done that, we again can push to our remote to keep it up to date. And you can actually look at what is happening in the background in Visual Studio Code, and a lot of stuff will appear, but the important line is git push origin master master. So that means that Visual Studio Code actually uses exactly the same syntax as we would use on the command line ourselves. And then we can go on GitHub and explore a little bit the history of our little repository. So now you can see my changes that I made in Visual Studio Code appeared, and also the commit message with it appeared. And that's really kind of like starting to get into that workflow of committing changes and pushing them and looking at them. And now we can go back to our summary. So we have now learned about the staging area and working copy. We learned about git status, which is a really useful command, which you should use as often as you can. We learned how to commit a change and how to push and pull our changes and interact with the remote repository. And when we explore the history on GitHub, we can also use it locally because it's the same content. The difference, basically, this is the same commit, just differently presented. And personally, I find it a little bit easier to see what's happening on GitHub because on the terminal, it just shows a lot of other things that might not be so useful sometimes. But sometimes it's also really nice because on the terminal, you basically have the full power, but also the full responsibility. Just to show you that, you can also commit from the command line. So now I'm making changes again in Visual Studio Code. I'm deciding I need to edit that line, but it's also getting a little bit too crowded. So I now deleted something, which I don't want to have in my code anymore. And I think that's another really nice feature of having this version control. It allows you to write clean code because you can freely delete anything from the current version, but because you have the history and you can go back any point in time. And we call git status again, and it will show us, okay, we have modified the README, that is true. And we add a commit, or we do our commit and add a commit message. I wanted to clean up my code, and then we push it to our remote repository, and we can see that our commit has appeared here now with the commit message. And when we look in there, we can really get this line-by-line comparison of what has happened. And for example, here we now can see I deleted something and then added a few more lines. And if you want to go back in time, one really useful feature is the search option in GitHub. So you can search for your commit message. If you know, oh, at some point in time I deleted something, or at some point in time I did that. If it's in your commit message, then it's really easy to find. And then you can go back to that commit and have a look, oh, what did I do back then? And for really kind of like small changes, there's kind of like a version to get that stuff back via Git. But for small changes, the easiest thing is probably to just copy paste it back in. And now if you look at our graphics, we can see we have uncovered everything. And for completeness, so git fetch is a command we don't really use because it's integrated in git pull. But what git fetch does, it just updates the local repository, so that little git folder, but it doesn't do any kind of like changes to the files, to our working copy. And git pull then does also git fetch and a merge, so it now updates the local repository and incorporates the changes from a remote repository into the current branch. And that's what you want to do most of the time. That's why this command was created. Now you might think, okay, this is a great thing to do. I'll just put everything under version control so I can go back to any point in time. It's, and you might think, okay, not only the code, but the data, my literature, everything. I want to have everything on Git. But that's a really terrible idea.
Yes, the reason why is, and we already alluded this bit in the earlier slides, is Git works based on differences. So it always takes a difference of the files you make, and then it creates a checksum. So it's an algorithm that basically makes sure that every change happens, has a unique identifier. And the problem is when you commit a file that's 600 megabyte, for example, like a brain imaging big file, then what will happen is creating these checksums will take a very long time, because in order to create these checksums, the computer has to look at every single byte to create this number. And this will take a long time. So if you just check in big files into Git, what will happen is it will take everything in Git will take very long, and it will get very, very slow to do anything. So for example, to check out a repository or to change a branch. And if you want to use, if you think Git is a cool thing and you want to continue down this rabbit hole, there is a tool that's called DataLet, and there is a really cool talk in this train track by Adina Wagner from Jülich, and she shows what DataLet is, and it's a tool based on on an extension to Git Annex, which allows you to handle big files. So they basically took this bottleneck of normal Git and made it work. So with Data-led and Git Annex, you can version control really, really big files, and it's extremely useful for this. So I very highly recommend to look at this talk. For literature, there is just a better tool, which is Zotero. So yes, you could check in PDFs in Git, but you don't profit from it. And if you want to share your results with everyone, then it's possibly better to put them on websites like the Open-Science Foundation, which have a command line tool to upload data, to download data. And also there, it has a nice Git integration. So you can actually have your source code on Git, you have your data on OSF, and everything is nicely integrated and working well and performant. And then for code, if you like this whole concept of Git, there's one advanced topics that we recommend looking into, which is continuous integration. And we'll show a little bit about this later. But what it means is, it means that when someone commits something to a repository, tests automatically run. And they make sure that the changes you make to the repository don't break the big project. Because if you work together with hundreds of people, or even if you just work alone, it's very easy to make a change on one end of the project and breaking something on the other end. And continuous integration makes you automatically checks for these things and makes you aware that, oh, the change you just made potentially broke something.
So our project is going so well that I could convince Stefan to join me. So I have to add him to the project, and I can do that on GitHub. When you go on Manage Access, and it tells you you want to invite a collaborator, and that's what we want to do. So we want to invite Stefan to help me a little bit out, and he gets then a message that tells him, oh, Saskia Baumann just asked you to join her on this repository. And when he accepts that, he can now see the repository and then get started on working.
Yeah, so now I'm able to log into this repository, and I was already able to clone it before, but now I can push changes as well. So, and just to show that Git is not just working in Windows, it's also working on Linux, and actually even better because most Linux distributions have Git already integrated, and also on Mac it's pretty easy. So you just open your terminal on Mac or Linux, you type Git, and it should be there. So the cool thing is the commands are identical to what we have already shown. So we clone this GitHub repository. Of course, for this to work, I have to set up my SSH keys. It also works the same as what we have shown on the slides already. Then I'm cloning my repository that I want to work on. And now there's one thing we want to introduce, and it's called branching. And branching is something really useful. It can be intimidating, and it might look complicated, but if you just think about it, if you want to add a new branch, you want to do this if you implement a new feature, and then it gets actually really simple and very useful. So what you would do is you click on this branch master. So master is always the default branch. This is where the code should be that's running, that's working, that's tested. That's the code you release to other people. And then if you do something new, you usually want to create this new branch. So you click on this, you say create branch, and then you give it a name, for example, testing fancy feature, or developing new feature, or creating a bug fix, for example. So you create this new branch, and then you can see these branches when you're on the repository. You see now this repository has two branches, and when you click on it, you see there's a master branch, and then there's a branch that I just created, and now we can work on that. So just to explain a little bit what's going on under the hood. So we have our remote repository. In there, we have the master branch, which is the main branch. This is where we keep the stable code. And then all other branches, see them as you want to test something, you want to fix something, or some people even keep release versions in branches so they can go back and make, for example, fixes to a certain version of the code they released to someone else. You find this nice graph overview to see these branches, and in Insights and Network Graph. Other tools like GitLab, for example, show this also quite nicely. But yeah, you see we have our master branch, and then here in blue, we branched off into our testing branch, and then here you also see we merged it back later and then we're back to the main branch. So you nicely see why it's called branching, because the master is the tree, and then from there you branch off in little things. And sometimes you might not want to merge it back. So if you're just testing something, you can also just abandon the branch. And the cool thing is you haven't messed up the history, and you haven't disturbed anyone while testing something in the master branch. So we're doing this now. So I'm pulling this repository, and now I'm seeing there is a new branch because I created that online. So we're pulling this branch, and then we're checking out this branch, which means that we're switching our working copy to be that branch. And now I can use my favorite text editor. In this case, I just use VI, but you can use Nano, you can use gedit, whatever you have, and you edit the files you want, or Visual Studio Code. So you add a new feature, and then you make well, first you check what did I do. With git status, you see now there is a modified file, readme.md. Great, that's what I changed. So I want to create a commit, and I say I added this new feature. So the problem is, what's very often happening is you try to do a new feature and it seems to work, you commit it, and then you realize, oh, it didn't work. And you go back and you have to tweak the new feature. So you go back and you add more things and you create new commit messages. And now when we look at the log, at the history of our project, we see that Saskia just had nicely cleaned up the code on this snapshot. So 6.3b, this is this checksum that Git does. This identifies the status of the code. And now we see that I made two new commits, 4.6 with added new feature and 8.4 tweaked new feature. Now, if I would merge this back to the master branch, it would be not so cool because I needed 2 lines to do a simple thing. And very often I need more than 2 lines to do a simple thing. So it becomes very cumbersome for the people in the master project, because suddenly there are 10 messages of me trying to do something and fixing typos. So it would be really cool if we combine these two into one thing to make it easier for the rest of the team to understand what I actually did. And this is one really cool thing that I want to show. It's called squashing commits. And I think also one of the developers of Git said, this is one really big advantage of Git. It makes a coder look to be really good, because you can rewrite the history and you can make it look like you're actually good in coding. So what you would do is you do a Git reset and use a soft reset. And then you reset it to the commit where you branched it off. So in this case, it was Saskia's last commit. So C6B55 and so on, where she cleaned the code. So I'm resetting the repository to there, but the working directory is still the latest thing I did. So now the log is clean. That's great. And now I can look at Git status again, and it will show me that Git detected that README is changed because I haven't changed my working files, or I changed them manually, right? So this is where my new features are all in there. And now I can make one new commit message where I say git commit, I implemented this new feature and I tested it and it's actually working. So this now created a new commit. And now you see that we only have one line, and it's also a new checksum because now it combined both changes into one commit. So this is now something different for Git. And this is really cool. So we cleaned that up. Now the question is, did I really change history? No, you can't change history, you shouldn't. What we only changed is we changed the log history. So the log history is what people would usually look at. This is what's displayed by default in GitHub. But Git actually keeps track of what really happened under the hood. So if you look at this full history, it's called reflog. And if you look at this, we see that we actually see everything. So I see that I cloned from Saskia's original thing. Then we see that I checked out a different branch, which was my new feature. And all these things are not in the normal history, but they are in this ref log. Then we see that I made a commit, I added a new feature, then I found a typo, so I called it tweaking the new feature. And then I was embarrassed that I needed 2 commits to do this, so I reset the repository. So I moved back to C6B556D, and then I committed a new change where I then relabeled my change and I said new feature implemented and tested, because now I actually fixed that typo. And now it has a new commit. And now I'm happy. So I check commit, check the status, and I'm happy, everything is committed, the working directory is clean, and then I can push. So now I'm sharing my changes with the rest of the world, and now it makes me look like a really good coder because I implemented this feature with one commit, and I didn't do a mistake, right? So now ready to merge. The cool thing is when I do this on GitHub, there will be a little message, compare and pull request. So I'm clicking on that and I'm saying, look, I implemented this new feature. I added this new feature. It's ready to be merged. And now I could potentially merge this myself because I'm actually now a contributor to the project because Saskia added me. But good practice is that actually someone else reviews what you did. So that would be now in a code review. So someone looks at the changes, makes sure they're plausible. Ideally, you also have continuous integration set up. So your commit is actually checked if you broke something else in the code. But now the next person in the project takes over.
Exactly. So now we have the pull request from Stefan. I see it. And I now log in with my credentials onto the repository. And it shows me that he made a new feature, has this new branch, and he wants that new branch like integrated into the master branch. And he asks me to check what he did was plausible. And once I go back through the code, I can merge his pull request. So that means kind of like integrating his changes from his testing branch into the master branch. And I also write him a little text message and say, thank you for your work. Thanks for your contribution. And this again is also a commit, so a change to the repository. And once I have confirmed this merge, you can see the comments and as well that the pull request was successful and merged, and you can even delete the branch if you don't want to keep it. Now our history is nice and clean. If we go back and look at it, so we have the one commit for the new feature, and we have the merge commit that tells us this new feature has been integrated into the master branch after testing. And that's kind of like how you work in a project when everyone has access to the project. And it's very similar when you want to contribute to a project where you're not part of the development team in the sense that you have access or push rights to the repository. So everyone can pull, but not everyone can push. And for that, we've chosen the hackathon example. So the team has set up a really nice short example on how to use Git and how to actually contribute a little bit to the OHBM website. So when you go on the OHBM Hackathon 2020 repository and you have a look at the issues, they have one pinned issue there, how to add your own image to the venue page. And that's a really good exercise on how to use Git with all the steps in there. So we will just quickly go through that. The idea is that everyone adds an image to the venue folder, which is then displayed online on whatever they're set up for working at home or whatever, maybe in an image of you, and also modify a file and then commit, push, and pull, make a pull request for these changes. So it looks a little bit more interesting on the website. And we just need to follow the description along. So the first thing is to find an image, which I've already done. And then we fork the repository now. So that means you create kind of like the same repository, but in your local GitHub account where you have rights to make changes. So that's one more step we have to do, but it's pretty easy. So instead of cloning, we go back to the code. And instead of cloning, this time we click on fork. And then it asks us where should we fork this Hackathon 2020 repository to. And I'm picking Stefan's account now, because this is the second round of doing that. So don't worry if it doesn't work out right away. And it will tell us it's forking now. It will take a few seconds. When that's done, it will appear in your GitHub account. And then you follow exactly the steps along. So you want to clone the repository and you want to create a new branch on which you add your image. Good. So we go on git clone, and now this is no longer the OHBM repository, but this is now Stefan's own repository where we have forked. the repository too. So we clone it, for example, using the command line. This takes a little bit because it's already pretty big, which again shows kind of like why you only want to have small files if possible. Then we change to that directory, we create a new branch, we check out this new branch, so our working copy is now on the new branch. And then we add our image file to the folder, which is really just copy pasting it to into the correct folder, which is image and venue. And then we also have to modify the YAML file that describes the venue web page, so our image gets added to it. And we just have to give it a name and the name of the image file. And for example, we can use a normal text editor, or we can use it with a Visual Studio Code, where you right-click on the background and then it automatically opens the whole folder for you. And once you've done that and you found the correct file, you now start to make your changes. And really important, add that little minus there, because otherwise it doesn't work. Once you've done that, you know what to do. So you commit your changes, and you add all of the files you changed. So git add will add the YAML file that you changed to the staging area, as well as the new image that you just added. So let's have a look at it. Where we call git status, it shows us one file has been modified and one file has been included, which is not yet tracked. And also Visual Studio Code will give you exactly the same information. So you can see the little M next to the venue file, that means modified, and you can see the U next to the image, which is untracked. And you could now commit from Visual Studio Code, or we just follow the instructions here. We just do it on a command line, and then yeah, we just make a commit message that says, okay, who added the image to the venue page? And then we update our GitHub repository with the changes we made locally, which is just git push. And again, we run into a little problem here, but luckily Git gives us the solution. And the problem is that we have created the branch locally, and we didn't tell the remote repository about it. And once we do that, we get a successful git push, and then we can go to the last step for us, which is creating a pull request. And the easiest is to just go again to your local repository, and GitHub will already ask you, hey, you made some changes. Do you want to compare and create a pull request? And it's really important that this is your local repository, not the OHBM one. So when we click on compare and pull request, it will tell us that the branches can automatically merge. So we haven't really broken anything or introduced any conflicts. And then we write a little message, just thank you for being awesome. And then we create this pull request by clicking here. And at the bottom of the page, you again get an overview of the changes you made. So you can see we added 3 new lines, and we also added an image that go along with it. And just make sure that that image is really, really small, so just a couple of kilobytes, because our repository will get really big and very slow. And now, because we don't have any access to the repository, the team on the OHBM side will now have to actually make the merge. So we just have to sit and wait, and they actually have some continuous integration in there, so that will run, and once that's done, shows, oh wow, all checks have passed, so that is good, we didn't break anything. And once someone from the team has reviewed your changes, you will get a little welcome message from the bot. It says thank you for contributing, and once everything is done, you get a congrats message and some bragging rights for your first fork and pull request. And often you also get a little comment from one of the authors, says thank you, and you can see that the pull request was successfully merged and closed. And if that was a little bit too quick, Stefan will quickly summarize what has happened.
Yeah, so just to summarize, what's collaboration in Git looking like? It basically puts everything together that we talked about today. So we know remotes are the repository stored on our computers, and we learned already earlier that there can be multiple remotes. So now we have actually two remotes. So we have the origin, which is the repo where I cloned from, and we have now upstream, which is the repo I forked from. So how does this look like? So the OHBM has this Hackathon 2020 repository on their website. We are not members of this repository, but we want to contribute. So what we will do is everyone can fork. So fork is basically a clone, but it's not a clone to a repository, it's clone on GitHub. So this means we're taking this Hackathon 2020 repo and we're copying and linking it into our account. So this repository always knows where it came from. So it knows, oh, I have a relationship with this OHBM repository, and this is what makes it work, and these buttons appear, like create pull request and merge and all these things. So this is why it knows where it came from. Then we have to change it, so we have to clone it to our local computer. So we do this, and there's our local. Then we have now two remotes. The remote one is origin. The remote 2 is upstream. Or we call that upstream. That's the Git language, how people call it. You can call it however you want. You can also rename it. So we pull from this origin, we push changes up there, and then we make a pull request, which means we invite the original authors of the project to pull changes from our fork. And they can then decide if they want to make changes to these changes, or if they want to reject it. Maybe sometimes it just doesn't fit what they wanted, and they will just say, no, we don't like to, or we can't really use your contribution. So this can happen as well. But very often, everyone is happy if you help them out in your project. So yeah, that's it, what we wanted to talk about today.
So thank you. I hope you enjoyed it, and I hope we could convince you to give Git a try. So we have a little break now, I think, and then some time for question and answers. And yeah, if you all could give it a try and see if you can contribute to the OHBM website, that would be really fantastic. Thank you.
Thank you. Bye-bye.